Got another exam question here on the AS Analytical Techniques topic. As always, the link to the questions in the description of the video if you wanted to try it first. Okay, so we'll make a start. So we're told that compound F is a trans stereoisomer. So that means we've got to have a carbon-carbon double bond in the molecule, and we're going to have two identical atoms or groups of atoms on diagonally opposite sides of the carbon-carbon double bond. So we'll need to factor that in when we've got the structure sorted. So if we move into the other information now, so we've got some percentage composition by mass. So obviously we'll work out the empirical formula from that now. So that's given us an empirical formula of C4H6O. So it's always a good idea to work out the MR of that straight away. So that's coming out at an MR of 70 for the empirical formula. So I know the infrared spectrum's next on the list, but if we jump to the mass spectrum and we look at the peak furthest to the right, its M over Z value is 70. So that's telling us that the MR of the molecule is 70. So therefore the molecular formula must also be C4H6O. So we'll stick with the mass spectrum just for a little bit longer. So we are told in this information here that the peak with the greatest relative intensity in the mass spectrum is caused by the loss of a functional group from the molecular ion of F. So basically, going from here to here, we need to work out what the drop in mass is, and then that's going to tell us what the MR of the functional group needs to be. So this tall fragment peak is at M over Z 41, so 70 to 41 means that the functional group must have an MR of 29. So we'll look at the infrared spectrum now. So remember, we've established that the molecular formula is C4H6O. So there's two areas I always look at first on an infrared spectrum. I look around the 3000 centimeters to minus 1 mark, and I also look at the sort of 1700 centimeters to minus 1 mark. So we have got some activity here around about 3000 centimeters to minus 1. So could this be an OH of an alcohol? No, because that needs to be sort of a little bit higher. So it's not that. And we can't have a carboxylic acid because we've only got a single O. So these must be CH absorptions. And then if we look at this part here, we've definitely got an absorption at about 1700 centimeters to minus 1. So this has a C double bond O. So I've just summarised everything so far into what would be my answer. Okay, it's not quite finished yet, but I'll just quickly go through it. So we established the empirical formula was that. We worked out the MR of the empirical formula to be 70. We then went to the mass spectrum. We saw that the molecular ion peak was at 70. So the MR of the molecule is 70. And so the empirical formula and the molecular formula must be the same. We then jumped to the infrared spectrum and we found out that the molecule didn't have an OH group of an alcohol, so because it hasn't got that absorption in the alcohol range. Remember, we did rule out carboxylic acid because there's only one O in the molecule. We do know that it's got a C double bond O because the absorption was there at around about 1700 centimeters to minus 1. The fragment peak at 41 was due to the loss of a functional group with an MR of 29. So we know it's got a C double bond O. So that functional group is a CHO functional group. So this is going to be an aldehyde. So with the atoms we've got left, we're going to have to put hydrogens across here to make it the trans option. So therefore this is a methyl group. So that is the answer.